Okay, we're recording now. Thanks, Thomas. We are going to be working straight out of the textbook. This is from page 347. Everybody say hi, Becca.
Hi, Becca.
Hi, Becca. Okay, we miss you. Hope you're having a great time at Baylor. If a function f is differentiable on an interval I, and if f has an inverse. Okay, so let's think inverse functions. How do I find a function's inverse? If I know their inverse. Okay, so to find inverse functions, I swap x and y. Okay, so generally that's kind of the steps we go through. We swap x and y, and then we solve for y. So that's how this is working here. They have the function f. This is the blue one. F of x equals 2x plus 1. Can you see that? They swap x and y. So now x is equal to 2y plus 1. And then we solve for y. So we're going to subtract 1 from both sides. 2y is equal to x minus 1. Divide that by 2. And now we have this green function. Y is equal to half x minus 1/2. You see where we're getting the green and the blue? So f was the original. F inverse is the green one. Okay. The slope of the original function was 2. The slope of the inverse function is 1/2. So on perpendicular lines, the slopes are negative reciprocals of one another. On inverses, they're not negative reciprocals. They are what they call, I'll try to say this without stumbling, multiplicative inverses of one another. Multiplicative. So what that means is you ought to be able to take the slope of your first line 2 times the slope of your second line 1/2 and get 1. That's how you know you're dealing with inverse functions when they're linear. Okay? The slopes should multiply and make 1. The result is apparent if f is linear and helps to explain the general differential rule for inverse functions. There are a couple of things that you need to note out of this slide. If a function f is differentiable, that means my original function f is differentiable. And if f is also invertible or it has an inverse, then it seems reasonable that if f inverse is also differentiable. Okay, so if I have f is a smooth function, no sharp edge or corner, then its inverse is also going to be a smooth function, no sharp edge, no corners. That's pretty much understood. That brings us to this. It says the graph of differentiable function f, that's the blue one. Okay, f is this blue one right here. And its inverse function, f prime, or f inverse, not f prime, f inverse, are shown. Let the point xy lie on the graph of f inverse. Another way to tell if you've taken inverse functions well is they should be symmetric on the line y equals x. You remember doing that before? Okay, so let's say I have some kind of parabola, y equals x squared. When I take its inverse function, I should get y equals the square root of x. Those two functions are symmetric on the line y equals x. You should have remembered that from pre-cal, from Algebra 2, we did it a lot. Okay, so if you can tell that the point xy lies on the graph of f inverse, so somewhere, then f inverse of x must be y. That's how that works. So we're saying let xy be on the point f inverse, on the function. Then we know that f of y must be x. So they're backwards. If on f inverse I get x comma y, then on f, I get y comma x. Let's go back to the parabola. I'm seeing lots of furrowed eyebrows. Okay, so we're going to let y inverse be the square root of x. Okay, that's going to be this function right here. Let's plug in a nice easy number. Let's do 4. Okay, so plug in 4. What's the square root of 4? Okay, so that locates me at the point 4, 2. Right? This is my inverse function, and I have the point 4, 2. What that means is on my original function, the one that wasn't inverted, which would be y equals x squared, I should have the point 2, 4. 2, what's 2 squared? 1, 2, 3, 4. 2, 4. So for xy on the inverse, I get yx on the other one. Is that better? Okay. All right. It also has information here for f and f inverse with their respective tangent lines. Okay. We know that L2, which is the tangent line on f inverse, and L1, which is the tangent line on L2 is on f and L1 is on f inverse. We know that those tangent lines should have slopes that are inversely related, right? This gets very, very, very weedy, and so I'm going to try to cut to the chase here. L1 is the reciprocal of L2. They should be because they're running on inverse functions. L1 should be the reciprocal of L2. So write this down. This is our equation. The derivative of the inverse function, so this is f inverse prime of x, f inverse prime of x, the derivative of the inverse function is going to be the reciprocal, so 1 over the derivative of the inverse of x. Whole lot of rub your head and pat your tummy, or rub your tummy and pat your head. This is just a whole lot of thinking backwards. Okay, this doesn't have to be super confusing. I do think that the way that they outline it in the textbook makes some sense, but it's really weedy. So again, I would prefer let's just cut to the chase and kind of get into it, see what happens. Write this down underneath where you're writing your function. Okay, so f inverse prime of x. What this is saying is the derivative of the inverse function. The derivative of the inverse function. You're going to need to memorize this equation right here. 1 over f prime of f inverse of x. In order to rememberize it, I think we should say it. And I want you to write what we're saying. 1 over f prime of f inverse of x. 1 over f prime of f inverse of x. Okay, everybody together. We're going to chant it like it's a seance or something. 1 over f prime of f inverse of x. Everybody say it again. 1 over f prime of f inverse of x. Again, 1 over f prime of f inverse of x. If you can memorize that formula and you can use it, you're set. Okay? Don't worry about why that is the formula or how that is. That's the theoretical part that we just kind of tried to look at. Don't worry about it. I think we particularly get a rule, cut to the chase, use it. So the rule here is 1 over f prime of f inverse of x. Okay? Knowing that, we can go straight into example 7, which says the function f of x equals 3x plus e to the x. It is 1-to-1 and differentiable. 1-to-1 means you can invert it. Differentiable means so is its inverse. Its inverse is also differentiable. Okay. Find f inverse prime of 1. So find the derivative of f inverse at 1. That's what it's asking. Find the derivative of the inverse function at x equals 1. What again? What? F of x equals 3x plus e to the x. Example 7? This should be on 248. On 248. Derivative of an inverse function. And so what we're trying to find is f prime of f inverse of 1. Okay, so this is where we start having to kind of pat our tummy and rub our head and hope that we can work out some magic here. F inverse prime of 1 is the goal. Okay, we know that that is equal to what? What did we learn?
1 over f prime f inverse of x, which is 1.
Of x, which is 1. This actually is a lot nicer than it looked. This formula lets me start on this little inside peanut piece of information. Right here. Okay? 1 over f prime of f inverse of 1. So let's start in the middle. What is f inverse of 1? So you got to read backwards here. F inverse of 1 is saying when my output on f is 1. Okay, so this 1 right here, this is the output because it's f inverse of 1. This is saying f inverse of 1. If that's x of f inverse, then we're talking about y of f. Okay, it's inside out and backwards. F inverse of 1, this is the output of f of x. Okay, so what that means is my f of x equation had to equal 1. So 1 is what we get out of 3x plus e to the x if x is what? No. If x is 1, I get 3 plus e.
When x is 3 plus e.
So we're working backwards here. We're trying to solve for x. Yeah.
0.
I get, if x is 0, I get the 1. Okay, if x is 0, I get 1. And so what we're doing there is we're saying, what could I plug in for x? What is my input such that my output happened to be 1? Are you following that? So kind of look at it, try some numbers. You got to have some intuition about you and how this function works. But it works if I plug in 0 for that x. Because e to the 0 power is 1. 3 times 0, that's 0. So I get 1 equals 1. That works if x is 0, right? So what we're seeing here is that f of 0 is 1. That's what we just said. F of 0 is 1. What is f inverse? So go back to this function right here. F inverse of 1 is 0. Ah, now we're cooking. Now we're moving some things around. It's like a log jam, and you just got to move one log, and then things can start rolling, right? So your first job is to start with this inside piece of information, this right here, and go solve it and figure out what is f inverse equal. The way you do that is you set your f function equal to that output, and you work backwards until you figure out what the input was. Once you know the input value for f, you can swap it out for f inverse of the output. You seeing what I'm saying? Because now I know that f inverse of 1 was 0. Okay? So now, and yeah. So now we have 1 over f prime of, instead of f inverse of 1, 0. Oh. So what's f prime? You got a function f.
Oh, we derivatized that.
Right? So we have f of x equals 3x plus e to the x. What's f prime of x? 3 plus e to the x. So what's f prime of 0?
3 and 4.
3 plus e to the 0 power, and that guy is 1, so 4. So now we can substitute, instead of 1 over f prime of 0, we know f prime of 0 is 4. We go right into that equation, that function. 1 over 4. Take it right here. 1/4. That's it. That's my answer. 1/4.
It's a lot better than what I thought we had to do. I thought we were going to have to chain rule all this stuff.
But you've got to know the equation. 1 over f prime of f inverse. So you start with your f inverse piece, work it backwards with your function, and figure out what, if this is my output, what was my input. Substitute that out, and then go take the derivative at that value, put it under 1, and you're good. I mean, that sounds like a lot. But, okay, so let's look. That's the only example in the book for this part. So I want to look with you at some homework, and let's see how many questions we can crank out that are about this thing in the homework. And we'll just work until, the bell rings, and then we'll stop recording. So if it ends on a sour, weird note, sorry.
Does it drop in?
12. Start with AP number 12. This is in your assignment. At what time? Noon? Sweet. So we might get a couple of them. Okay, so I don't have the pictures for these because I didn't know how many of these we might get through, so I'll just have to handwrite the problem on the screen. Is that okay?
Yes.
This is number 12 from your assignment. It says, suppose f of x equals x cubed plus x squared plus 2x. X cubed plus x squared. Oh, geez, Louise, this is going to make me mad. F of x equals x cubed plus x squared plus what? 2x. Okay. If g of x is f inverse of x, if g of x is equal to the inverse function of x, f inverse of x, what is the value of g prime of 4? Find g prime of 4. Okay. So it says find g prime of 4, knowing that g is f inverse of x. So really what I'm trying to find is f inverse of 4 primed, or f inverse of x, because g of x is f inverse of x, right? So I'm trying to take the derivative of the inverse function. Great, I've got a formula for that. Anytime this is my setup and I'm taking a derivative of an inverse function, I get to jump straight to my formula. So g prime of x is equal to f inverse of x prime. Right? That's what it's saying. G prime of x, because g and f are inverses, then if I do g prime, I'm actually doing the inverse, or the derivative of the inverse function. I've got a formula for that. 1 over f prime of f inverse of x. And what we're finding in this case, because x is 4, is we want 1 over f prime of f inverse of 4. Now we can go to work. Our first task is to go in there and figure out what is f inverse of 4, which means I want to set my f of x function equal to 4. And we need to figure out what could x be so that that's what I've got. what could x be so that my answer when I plug in that number is 4? 1. Ooh, that's the hard part. Reading this function and figuring out what could I plug for x that I output 4. If I put a 1, I got a 1 and a 1 plus a 2 times a 1. I make the 4. I always start with 0 and then kind of go up from there. It's just intuition. You could solve it. Like you could work it backwards. You could figure out the x, and I think it's better to just kind of look at it. Okay, so I know f of x equals 4 when x is 1. So I can say f inverse of 4 is 1. Why? Because f of 1 is 4. Are y'all following that train of thought? Okay. So in my little equation over here, 1 over f inverse or f prime of f inverse of 4, I get to swap out f inverse of 4, and instead I get to put 1 because f inverse of 4 is 1. Yeah? Now what do I get to do? Go find the derivative of f. Let's do that first. If f of x is x cubed plus 2 or x squared. Oops, I was already doing it.
3x squared plus 2x plus 2.
Okay. F prime of x, 3x squared plus 2x plus 2. Y'all are a step ahead of me. Now I want f prime at what?
1.
Okay. So 3 plus 2 plus 2, 7. Now I get to 1/7.
Yep, okay.
Yep. Whew. 1/7. What do you think?
Good.
1/7 is my answer. So once I find the derivative at that point, I go straight to the bottom with it. Okay?
Yep.
Let's do another one. 13. 13. They say suppose, anytime they have you supposing, you know it's scary. Suppose g of x equals f inverse of x. G of x equals f inverse of x. This is number 13, by the way. 12. Suppose g of x equals f inverse of x. Okay? This is kind of one of those times where you start saying, say less. I know what to do now. F of 1 is 0. These are just clues, facts that they're giving us. F of 1 is 0, and f prime of 1 is 3. Okay. What is the value of g prime of 0? What is the value of g prime of 0? That's what we're finding. So now I know g is the inverse of x, which means g prime of x is f inverse of x primed, right? Except this thing is nasty. We don't operate with that. Instead, we have a formula for it. What's my formula? 1 over f prime of f inverse of x. You following that?
Yeah.
Now, we're actually finding 1 over f prime of f inverse of, what was my g of 0? G prime of 0. So now I take this little piece of information right here and I start traveling it backwards. If f inverse of 0, right? So what this is saying is f inverse of 0 is something. I go to my f equation, which they didn't even give me.
Right.
But they said, hold the phone. If x is 1, my output is 0. So f inverse of 0 must be 1. Is that making sense? You got to read it backwards. So f inverse of 0 is 1. That means I'm subbing this out, and instead I'm plugging in the 1 right there. Yeah, wasn't that sweet? So now we have 1 over f prime of 1, and they told us that.
1/3.
Ta-da! Right? You like this better?
Yes.
Good.
The answers aren't like super.
Yeah. These to me are like, kind of like Sudoku puzzles. Like, you're working it and it's a puzzly kind of thing, but it's not awful. Does that make sense?
Yeah.
These don't work as far as derivatives of your inverse trig functions. That's not what this is. These are not inverse trig functions. These are inverse functions. Okay, let's go on. We've got a little bit more time here. There are a couple in your homework that I think are going to get snazzy. So let's try to jump to those. Let's go to number 107. Look first at 106. 106 is much like the one we just did. Can you see that?
Yes.
106, it's going to have a lot the same setup. 107 is snazzy. It's got a table. Okay? I don't have time to put the table down right here on these notes. Not if we're going to finish it. So we're going to, Becca, reference the table. Okay. Page 251, number 107. So suppose P is a differentiable function. The table gives values for P and P prime for x equals 4 and x equals 5. Find J prime of 4 if J is the inverse of P, right? So J of x is the inverse of P of x. This is number 107. Page what? 251. Okay, so I'm supposed to find J prime of 4. Well, if J is the inverse of P, then I'm going to have J prime of x being the derivative of the inverse of P of x. Right? And anytime I'm taking the derivative of the inverse function, I use my formula. The derivative of the inverse function is equal to 1 over P prime of P inverse of. Is this why I had you memorize it? Right? 1 over P prime of P inverse of x. We are looking for J prime of 4. So we want 1 over P prime of P inverse of 4. P inverse of 4, we've got to reference our table. P inverse of 4, so we're reading our table backwards. Hold on just a second. On our table, we've got x is 4 and 5, P of x, and I know, but we can't do it without looking at the table. Poor Becca. I want to cry. P of x is 10, 4, 8, and 9. Okay, the question is, what's P inverse of 4? So when my output is 4, when the output is 4, what is the inverse? So don't go to P of 4, right? Anybody can do that. P of 4 is 10. Ooh, ah. No, the output is 4. Okay, so P inverse of 4 is 5. Why? Because P of 5 makes 4. Okay, so we're going to swap that inverse of 4 out. 1 over P prime of 5. And now I get to read my table straight. What is P prime of 5? 9. So my answer is not 9. My answer is 1/9. The 1 over thing. It's got to be the reciprocal. Okay. There are more of those. You got to do 108 and 109. Yeah. 108, 109, and 110. They all fall under this category. Okay?